Hey everyone, welcome to this new lecture on coordinate geometry. In this lecture, we'll be talking about coordinates of intersection between lines. Many times you would see that on the graph and in equations there will be two lines or maybe more than two lines. We'll be concentrating on two right now that will intersect each other. So there has to be a way to find the common point between these two intersecting lines, and there has to be a way if there is a line which is passing through this common point. So basically what I'm talking about is if there are two lines and there's a third one passing through a common point, so what will be the equation of that line? So main objective of today's lecture is to find out how to find out the equation of the line that's going to pass through the intersection of two lines, and also the coordinates of intersection between lines. So basically it's solving the coordinates of two intersecting lines to find the common point or intersecting point between those two lines. So this is the first thing that we're going to do, that if there are two lines that are going to be shown on a graph and they are going to intersect each other, how are we going to find the common point or the point of intersection, that is what the point where those two lines meet? What is the procedure to do that? Now there is a procedure to do that, and the procedure is solving them in the terms of an equation or by solving them on a graph. Now if you see this example, for this is a pretty common easy example. We'll be doing more examples afterwards as well. So you see, the first thing that you have to do is plot these two lines on a graph. Now you see, this is a graph. You have y is equals to 2x plus 3 over here, and you have y is equals to 2x minus 0.5x plus 7 over here. So these are the two lines. Now they intersect over here. There is no way that you can find out what this point is, unless of course you have a y-axis over here which shows this is 6 and 6.1 or 6.2, and if you have an x-axis which shows decimal points as well. That is the way that you can find out how to solve this through a graph. But of course you can't get exact values of the intersection of these two lines through a graph, so you would need another method to solve this problem. So over here it shows that this common point is z. At this common point both equations will be same, but you don't have to get into that. Let's go to the point where we find out how to solve for the intersecting point. So the way to solve this is pretty simple. First we have to find the equation of the two intersecting lines, which we have. In the equation, y will be the subject and there is a gradient in the point in which the line intersects with the y-axis. When we find the equation of both lines, we consider them as equal to each other. As there is an intersecting point, the value of x in both equations will be the same. Now let's forget about this. I just wanted to tell you that it's no fun doing this just in a theoretical way. This is the theoretical answer to the question, but we have a better answer, and the way to go about this is that first of all you look at the graph. Now when you look at the graph, you'll see that the point of intersection has to be somewhere between x between 0 and 5 and y between 5 and 10. This you can confirm through a graph. So the graph basically over here, a graph like this is basically over here in order to confirm what your findings are, because if you find an answer later on in which it shows as x is 7 and y is 3, you'll know that there's something wrong with your answer, something wrong with the calculations. So how do we do this? That we use the two equations, we put them as equal to each other. That is, one equation was this 2x plus 3, the equation of this line, and the other equation was minus 0.5x plus 7, which was the equation of the blue line. So we put them as equal to each other. We solve for x. Well, how do we put them? Why do we put them as equal to each other? Because both are y. This over here is y is equal to this and y is equal to this, so we are just equating y is equal to y. So this over here is basically y is equal to y. This is the y for the for the red line, this is the y for the blue line. So we solve them, we do the calculations, we perform the calculations, and we get a value for x. When we get a value for x, we have this as 1.6 as the x-intercept, the x coordinate of the intersecting lines, and then we plug in x to this equation, that is to any equation. In fact, we just plug in the don't look at over here 2x plus 3. If you plug in this over here, you're gonna get this is not plugged in. 1.6 over here is not plugged in. So what do is you take an equation of y. You can take any equation of y. You can take y is equal to 2x plus 3 or y is equal to negative 0.5x plus 7. If you take y is equal to 2x plus 3 and you plug in the value of 1.6 over here, you're gonna get a value of y as 6.2, because 1.6 into 2 will be 3.2 plus 3 is equal to 6.2. So y is equal to 6.2 will be your answer. So the way to go about this is, the first thing is that you equate both if you have the equation of both the lines, the first thing to do is you equate both the equations. After you've done that, what you do is that you solve for x, you get x, and then you plug in the value of x in one of the equations and you get y. That is as simple as this, and this is the answer to your question. As you can see, it is in the range of 0.0 to 5 for x, and in the range of 5 to 10 for y, and this is your answer. Now let's go on to do another example to finding the intersection point, and also to find the line that passes through the intersection point. So moving on, now we find out a line that passes through the point of intersection and also the point of intersection. So first thing that we have to do is that we need 2 points, 2 equations of a straight line. These are the 2 equations that we have, and it is shown that there is another point on the graph, that is 1, 2. We're not going to use the graph on this because I just wanted to show you the graph, that how it is useful for your own understanding. So we have 2 equations over here, and we have another point. Now this point is not related to any of these equations. The first thing that we have to do is that we have to find the point of intersection of these 2 lines. Well, how do we do that? We basically solve for these equations. Now in this slide, in this example, we're going to do it in a different way. Rather than just putting y is equals to each other, we'll just subtract these 2 equations and we'll get rid of the y. So after bringing 1 on that side and multiplying throughout by 5, we get 10x plus 5y minus 5, because 1 over here will be minus 5. We subtract these 2 equations. Why are we subtracting these 2 equations? Because through subtracting of these 2 equations, we can get rid of the y. The same thing that we did in the previous slides. What we did was we equated both equations on y, so that way we got rid of y and we can solve for x. Over here, once again, we can solve for x by getting rid of the y. How do we do that? We make the y's of both equations equal by multiplying one equation by 5, because the other y is 5y. So then we subtract. After we are done subtracting, we are left with just one of the variables, that is x. So 7x minus 14 is what we have over here. We get the value of x is equals to -2. We plug this in to any one of the equations. We have plugged it into the first equation over here, that is 2x plus y plus 1 is equals to 0. Just like in the previous lecture, I showed you this. This is the same way that we're going to do over here. Same thing that we're going to do over here. So we plug in minus -2 over here and we get the value of y, that is equals to 3. So this is the point of intersection of these 2 lines, that is -2, 3. Now we have 2 points with us. One point is point of intersection between these 2 lines, that is -2, 3. And the other point that we have is 1, 2. So what do we do now? We have to find the equation of the line that passes through both of these lines. So we have 2 points on a line and we need to find the equation of that line. So now forget about the intersecting lines. We have done our part with that. This was just to show you, if you have 2 lines, how to find the common point between them. Basically treat them as simultaneous equations. The common point of x and y will be the point where these 2 equations are going to intersect with each other. So -2, 3. So -2, 3 and 1, 2. The first thing that we have to do is we have to find the gradient of this new line, that is m. So we find this gradient, this new line, by using the gradient formula that we learned already, that is y2 minus y1, that is 3 minus 2 over x2 minus x1, that is rise over run, -2 minus 1, that is x1 of the first point that we have. So the answer we're going to get is 1 over -3. This is the gradient. So now we have the gradient and we have a point. So all we need to do now is we need to plug it in. We plug it in into this equation over here. This equation is basically y minus y1 is equals to m into x minus x1. Now since we're treating 1, 2 as x and x1 and y1, we solve it for those. Y minus 2 is equals to -1 by 3 into x minus 1. So we solve this equation and we have the equation of the line that is passing through the point of intersection and that particular point, that is 1, 2. So we solve this, we multiply 3 on the other side, and we get 3y minus 6 is equal to negative x plus 1. We bring the x on this side and the 1 on this side. We get an equation that is x plus 3y negative 7, because 1 on this side would be y. Now this is one way of solving this equation. Remember that this is the most common way, and this is the most organized way in my view as well. But there are other ways as well, and we will see another way to do this. And the other way to do this is using this equation over here, this expression over here. I'm just going to go through this because maybe some of you might find this more helpful than the previous one. But the problem with this one is that you would actually have to memorize this expression, and you're bringing in another variable, that is k. You're already using these two equations over here, that is a1x b1y plus c1, a2x plus b2y plus c2. You're already using these two equations over here, but you're also using k. You're bringing in a new value k. Now that is the problem that there is. You need to make your life easier. You don't need to reinvent the wheel. So in order to do this, you need to somehow solve it in the most simplest way, and for me the most simplest way was the one that we already went through. But if you don't find it simpler, if this is much more simpler for you, then that's okay with that. Now there's nothing wrong with that. You can solve for this as well. So the way to do this is that you have the two equations, so you just plug it in. a1x would be basically, a1 would be the constant over here, 2, and x would be x, and b1 for the first equation. These are the constants for the first equation, these are the constants for the second equation. You solve these, and once you're done with that, you plug in the values. The values we have is that this new line that we were the main aim of our question was to find the equation of this new line. So we know the point of this. We don't need to find the point of intersection in this one. We just need the information about the new line. So the new line, we know that it is passing through a point 1, 2. We just plug this in. 2 into 1 plus 2 plus 1 plus k, 3 into 1 plus 5 into 2, because that is the value of y, and we just solve for this. When we are done with our equations, we are done with our calculations, we're going to get, this is a simplified form, of course, 5 plus 4k is equal to 0. Once we are done with that, we can get the value of k over here. Now what do? We plug in k. Now we have plugged in k, and all that we need to do right now is then we need to solve this equation, and we would have the answer to our question. So simplifying this, we take 4 as common and multiply the numerators, and after we're done with that, we simplify it further. We have a value in front of us, the value of equation, the equation of a straight line over here, 7x plus 21y minus 49. Of course we can simplify it, because as we see, 7, 21, 49 are both multiples of 7, are all multiples of 7. We simplified x plus 3y negative 7, and this is the answer that we have of the straight line through this method. Now if you see, if you go back to our previous slides, we'll see that this is the same answer. X plus 3y negative 7 is equal to 0, x plus 3y minus 7 is equal to 0. So basically you can solve it by either method, but if you were to ask me which method to go about, I would say go about the method of finding first the intersecting point, and then you solve for the gradient, and then you find the answer to the equation. Now the reason for that I find is because it is much more easier to solve the equation that way. It is much more easier to do it in a step-by-step way, because since it is a step-by-step way, you have less chance of an error, because you're going to be solving each step one after the other, and you can concentrate on one step at one time. Over here, of course, this is like a silver bullet. You just plug in the values and you have an answer. What if you get the value of k wrong? There's no way of finding out whether you get it wrong or right. So you just find out the value of k, and then you solve the equation, and then basically what you're doing is you're just finding out one value. You're just finding out k, and then you simplify. That is all you're doing. Over here what you're doing is you're basically simplifying the equation to get this answer. That is all that you're doing. But of course, if you do it the other way, the first thing that you need to do, I'll just sum up the points over there. The first thing that you need to do is then you need to find a common point of intersection. The way to do this, that you treat both the equations as simultaneous equations. Once you're done with that, you find the intersecting point. Once you're done with that, you have another point. You have 2 points in line that passes through those 2 points. So the way to go about that is you find the gradient and then you plug it in the equation of a straight line, and once you're done with that, you would have the equation of the line passing through the point of intersection and the new point. So basically what we've learned in this lecture is how to find the point of intersection between two lines and how to find the equation of the line if it passes through that point of intersection. So thank you very much. We'll be continuing further with coordinate geometry, and pretty soon we'll be introducing conic sections as well. So I hope you will be joining me in those lectures as well. Thank you very much.